Okay, today we are going to talk about ions. And an ion is an atom with more or less electrons than it is supposed to have. Let's say we talk about lithium. And lithium, its atomic number is 3, so that means it has 3 protons. Always has 3 protons. Its atomic mass is 7. So that means it has 7 protons plus neutrons. So from that, we can say that it has 4 neutrons. And we've been saying in a neutral atom, it is going to have 3 electrons. Because protons have a positive charge, electrons have a negative charge, and neutrons are neutral. So this is what lithium should be like. But when we take a look at an ion is going to act with different number of electrons. So if you remember back from the Adams Family worksheet, we had the nucleus arcade and it talked about streets. The first street could hold 2 enraged Elliott electrons. The second street could hold 8 enraged Elliott electrons. And for me, I am going to continue with that number of 288. As you go up in the grades, different rules are going to change a little bit. And I'm just going to my goal is for you to understand what type of an ion an atom will come. So if we take a look at these energy streets, or they're technically called electron shells, an atom wants either the shell to be full or empty. So if we were to draw lithium, it has 3 electrons. So that means it has 2 electrons in the first shell, and it has 1 electron in that outermost shell. And the electrons in the outermost shell are called valence electrons. And if we take a look at lithium wanting either full or empty, well, if it were to fill that next shell, that means it would have to add 7. Or if it wants to empty it, it needs to get rid of 1 electron. So lithium is going to lose 1 electron. And I like to say it's going to lose 1 negative charge. And if it loses 1 negative charge, that means then it's going to have a positive charge. Well, if we take a look at lithium, lithium has 3 protons. 1, 2, 3. So it has 3 positives now and 2 negatives. So lithium will have a positive charge. It will become a positive ion. In chemistry, you'll see that they'll just do Li plus, but I like to either do Li plus 1 or Li 1 plus. And by adding that 1 in there, it just lets you know that that you've finished the problem. Let's take a look at a different element. Let's take a look at oxygen. So if we take a look at oxygen, oxygen has 8 for its atomic number, so that means it has 8 protons and 8 electrons. Well, let's draw that out. If we have 2 electrons in the first shell, then to get to 8, we need to add 6. So that's 1, 2, 3, 4, 5, 6. So this outermost shell can hold 8, but it's only got 6 in it. So that means it's either going to lose 6, or gain 2. Well, it's easier to gain 2, so oxygen is going to gain 2 negative electrons. So if oxygen gains 2 negative electrons, that means it's going to have 8 protons and 10 electrons. And protons have a positive charge, electrons have a negative charge. So 8 protons, 8 positives and 10 electrons, that means oxygen is going to end up being a negative 2 ion, or 2 negative. You may run into a teacher or a professor at some point in your life who is going to become anal about this. That's not me. So let's take a look at another one. Let's take a look at neon. Neon's atomic number is 10. So that means it has 10 protons and 10 electrons. That's 2 electrons in the innermost shell. And that means that it's going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell. Well, its outermost shell is full, so it's happy. So when we take a look at neon, neon isn't going to form an ion because its outermost shell is full. And it's happy. We don't have to worry about it. It will not become positive, and it will not become negative. So if we take a look at the periodic table kind of on the big screen, let's see if I can get this out of here. We have what are called rows and columns, groups, or families. So if we go up and down on the periodic table, that's called a group or a family or a column. And they all have something in common. Let's take a look at beryllium. Beryllium has 4 electrons, and that means that it's going to have 2 in its first shell and 2 in its second shell. So it's going to have 2 electrons in its outermost shell, and it's either going to gain 8 or lose 2. So beryllium is going to want to lose 2 electrons. So beryllium wants to lose 2 electrons, and if it loses 2 electrons, it's going to act like it has 2 electrons. So that means it's going to act like helium. Magnesium is going to have 2 electrons in its first shell, 8 electrons in its second shell to fill it, and then it's going to have 2 electrons in its outermost shell. Well, that means it's either going to gain 8 or it's going to lose 2. So it's going to lose 2 electrons, and it's going to act like it has 10 electrons. So if it acts like it has 10 electrons, it's going to act like neon. And when we take a look at, some of you realized that on some periodic tables, or when you Googled how many electrons something had, you got something like 282. And that tells us how many electrons are in the first shell, how many electrons are in the second shell, and how many electrons are in the third shell. And if you notice, as we go down to this group, column, or family, they all end in 2. So all of these elements are going to have 2 electrons in its outermost shell. And they're going to want to lose 2 electrons, and they're going to want to lose 2 negative electrons. So that means this column, group, or, oh wow, that's bad. This group, column, or family are all going to end up being a +2 ion. Okay. Well, let's go over here and take a look at fluorine. Fluorine has 9, so that means it's going to have 2 in its first, 7 in its second, like it says right here. And in order to be happy, it needs to fill its outermost electron shell. So it's going to want to gain one negative electron so that it will act like neon. So it will have, if it gains one negative electron, it's going to have a -1 charge. Chlorine is 287. It's going to want to gain one negative electron and act like argon. Now, here's the kicker that's going to mess you up. I'm saying it wants to gain one negative electron or lose one negative electron. When we take a look at oxygen, the thing that pops into your mind is you go, oh, 2, 6. It wants to gain 2, and you'll want to call it a +2 ion. And that's not true because it wants to gain 2 negative electrons, which means that oxygen will be a -2 ion. Okay? So when you're talking through this, either out loud or to yourself, always add negative electrons. That will make your life easier. And we'll do a couple of worksheets to try making this a little bit easier on you. And if you have questions, don't be afraid to ask.